You spend days installing every optimization plugin on the market, configuring the settings, minifying the code, and waiting for the final scan to finish. The results come back showing a flawless 100 out of 100 on Google PageSpeed Insights, with perfect green metric indicators across the board. Confident in that score, the marketing team launches their biggest campaign of the year, sending a massive wave of real-world traffic straight to the domain. Instead of blazing speed, the live website stutters. Pages take seconds to render, images hang in mid-load, and the server struggles to breathe under the weight of thousands of simultaneous visitors. Days later, an email arrives from Google Search Console. The site isn't passing core web vitals. In fact, it is failing miserably. Speed test scores are controlled lab simulations. Optimizing for a bot without considering how the hosting environment handles a real-world crowd often leads to the exact performance breakdown we see during a launch. PageSpeed Insights operates in a synthetic environment, powered by automated lighthouse bots. These bots test from a single location, running a single request on a perfectly stable connection. Traditional caching plugins take advantage of this exact setup. They recognize the bot's signature and serve a stripped-down, temporarily cached version of the page, hiding the heavy PHP processing required for dynamic content. This masking technique successfully inflates the lab score. The bot reports a fast load time, but the underlying server infrastructure remains completely unchanged. Achieving a 99 in this vacuum only proves the site can render quickly under ideal conditions. It guarantees absolutely nothing about how it will handle the friction of the open internet. The true measure of performance lives in the wild. Google tracks this through core web vitals, relying on the Chrome User Experience Report, or CRUX, which pulls anonymized field data directly from actual human beings navigating the site. This field data ignores the lab score entirely. Instead, it measures real-world friction across 3 specific points of user interaction. The first is largest contentful paint, or LCP. It tracks exactly how long a user sitting on a weak cellular connection spends waiting for the main hero image to appear. The second is cumulative layout shift, or CLS. This records visual instability, the sudden jump of a page layout that pushes text down just as a user tries to tap a link. The third is interaction to next paint, or INP. This measures the frustrating delay between a user tapping a buy button and the interface actually registering the action. A single Lighthouse bot scanning a static cache is a lightweight task. But once you scale that up to a live audience, the server load moves from a single predictable request to a constant stream of dynamic events. The physical bottleneck is the origin server. Every dynamic human interaction forces that server to execute live PHP code and query the database from scratch. As traffic scales, these queries pile up. The server begins to choke, causing the time to first byte to skyrocket across the board. When the origin server reaches its physical limit, core web vitals plummet, and frustrated users simply abandon the website. Surviving the wild requires abandoning the traditional origin caching model and migrating to an AI-powered static edge architecture. This interface shows the Nimbica platform, built specifically to execute this architectural transformation and deliver websites 16 times faster. Instead of waiting for a user to request a page, Nimbica's AI engine analyzes the WordPress environment and pre-builds the entire site into optimized static HTML and CSS files before a single request is ever made. Looking at this global edge network map, we can see those pre-built static files are pushed away from the vulnerable origin server and distributed across more than 300 CDN nodes worldwide. This global deployment happens instantly. No manual developer configuration is ever required to move assets to the edge. By completely removing the live database and origin server from the delivery path, the architecture becomes inherently immune to traffic spikes. When the next massive marketing campaign launches, the high-volume traffic spike hits a completely different infrastructure. Thousands of concurrent visitors pull pre-compiled files directly from local edge nodes. The original WordPress server does absolutely zero processing work. The result is consistent, sub-45 millisecond load times for users anywhere in the world, achieved without stacking optimization plugins or bloating the database. This dashboard displays the real-world outcome. The field data verifies a past status for core web vitals. Zooming in, the largest contentful paint holds at 1 point seconds, and the cumulative layout shift sits at 0.026, all safely in the green despite heavy traffic. The site maintains speed because delivery no longer relies on real-time computation. This stability comes from shifting workloads to the edge. True metrics literacy means treating a 99 lab score as a basic diagnostic tool. Real success requires architecting your site for the wild to protect the actual human experience.